In January 2021, a team of scientists at the University of Bristol published something unusual in Current Biology. A peer-reviewed paper on a dinosaur's butthole. I'm going to let you sit with that for a second. This wasn't a joke, it wasn't clickbait. 3 researchers, including an expert on vertebrate reproductive anatomy, spent months studying the cloacal vent of a 130 million-year-old fossil. They mapped its pigmentation. They compared it to living crocodiles and birds. When CNN ran the story, the headline read, "This fossil reveals how dinosaurs peed, pooped, and had sex." But here's what didn't make headlines. This same fossil had already exposed something much bigger. Something museums around the world would rather you didn't know. This single dinosaur specimen is the only one on Earth where scientists can tell you its exact colour. Not guess, not extrapolate from living relatives. Scientists can actually point to preserved pigment cells and say with confidence this animal was dark brown on top and light underneath. And if we know the exact colour of this one dinosaur, that means we've been guessing about every other dinosaur in every museum you've ever visited. Let me show you what one fossil can do when science actually pays attention. The specimen sits in the Senckenberg Museum of Natural History in Frankfurt, Germany. Catalogue number SMF R 4970. If you visit, you'll see it lying on its back behind protective glass, looking remarkably fresh for something that died during the early Cretaceous. The story of how it got there is complicated. The fossil was likely illegally exported from China before the museum purchased it in 2001. There have been repatriation attempts, legal disputes, and academic controversy. But while ownership remains contested, scientists have made the most of the access they have, and what they have discovered justifies every bit of attention this fossil has received. This is Psittacosaurus. The name means parrot lizard, and at first glance it is not particularly impressive, about the size of a Labrador retriever. 2 legs, a beak like a parrot's, a distant early cousin of Triceratops, but without the dramatic horns or frill. The fossil was excavated from the Jehol deposits in China's Liaoning province, a region famous for producing spectacularly preserved specimens. It was purchased by the Senckenberg Museum in 2001, and almost immediately scientists realised they were looking at something exceptional. Most dinosaur fossils preserve bones. Some preserve impressions of skin. This specimen preserved the actual skin itself, and not just patches of it. Nearly the entire body outline is visible, from the skull down to the tail, covered in scales of different shapes and sizes. But the most unusual feature sat on the upper portion of the tail. Long, bristle-like structures, roughly 16 centimetres in length, were arranged in a row along the back. These were described in 2002 by Gerald Mayer and his colleagues, and they were the first evidence that ornithischian dinosaurs, the group that includes Psittacosaurus, Stegosaurus, and Triceratops, could grow structures beyond simple scales. They were not feathers exactly, more like the quills on a porcupine. They were hollow, tubular, and probably used for display. The museum put the fossil on permanent exhibit. Visitors could see this remarkably complete dinosaur lying there with its skin and quills intact. And for years that was the story. An unusually well-preserved specimen, interesting but not earth-shattering. Then Jakob Winther got involved. Winther is a paleontologist at the University of Bristol who had figured out something incredible in 2008. He realised that tiny structures scientists had dismissed as bacteria or artifacts in fossilised feathers were actually melanosomes. These are subcellular sacs that contain melanin, the same pigment that gives colour to human hair, bird feathers, and animal skin. Different melanosomes produce different colours. Long, thin ones create black and dark brown, round ones create reddish and reddish-brown tones. And, crucially, these melanosomes can survive in fossils for over 100 million years. Winther looked at the Psittacosaurus in Frankfurt and saw an opportunity. If he could map the melanosomes preserved across the entire body, he could reconstruct what this animal actually looked like when it was alive. Not a guess based on living relatives. An actual scientific measurement of its colour. The results came out in 2016 and they changed everything we thought we knew about how dinosaurs used colour. Psittacosaurus was countershaded. dark brown on top, transitioning to light on the underbelly. This is a camouflage pattern seen in deer, antelope, and many other forest-dwelling animals. The dark back absorbs light from above, while the light underside compensates for shadow, making the animal appear flat and harder to spot. But here is the critical part. The specific pattern of countershading tells you about the environment. In open habitats with direct overhead sunlight, animals develop a sharp transition high on the body. In closed habitats like forests, where light is diffuse, you get a more gradual transition lower on the body. Psittacosaurus had the forest pattern. The same rocks that produced this fossil also contain plant and wood fossils indicating dense forest vegetation. The camouflage matched the environment. Science had just used preserved pigment to determine where a 130 million year old animal lived. To test this, Winther's team worked with paleo-artist Bob Nichols to build a life-size model. Every scale, every bristle, every gradation of colour painted exactly as the fossil indicated. Then they placed a grey version of the same model in the Cretaceous plants section of Bristol Botanic Garden and photographed it under the forest canopy and under open sky. The results confirmed the prediction. The colour pattern on the Psittacosaurus fossil matched optimal forest camouflage. This model has been called the most scientifically accurate dinosaur reconstruction ever created. It looks nothing like what most museums show you. If you're finding this useful, hit subscribe. I cover stories like this every week where the actual science contradicts what institutions want you to believe. Now let's talk about that butthole. In 2021, Winther returned to the same fossil with two colleagues, including Dr. Diane Kelly, an expert on vertebrate reproductive systems. They noticed something that had been overlooked in previous studies. The cloacal region was preserved. A cloaca is an all-purpose opening. Reptiles, birds, and most vertebrates use it for defecation, urination, and reproduction. It's the Swiss Army knife of orifices. And in 130 million years of dinosaur fossils, no one had ever seen one preserved. Until now. The opening was V-shaped with discrete lateral lips that converge at the front. It did not look quite like anything alive today. Crocodile cloacas are similar, but this one had distinctive flaring lobes on either side. The outer margins were heavily pigmented with melanin. Why would a dinosaur have a colourful butthole? The researchers suggest it was used for visual signalling. Modern baboons display brightly coloured posteriors during courtship. Some salamanders do the same thing during breeding season. The dark pigmentation on Psittacosaurus would have contrasted sharply against its pale underbelly. The structure also suggested something about how this dinosaur reproduced. Unlike birds that mate through cloacal kissing, where both partners briefly press their vents together, the Psittacosaurus cloaca more closely resembles that of crocodiles. Crocodiles have internal copulatory organs. The researchers believe this dinosaur probably did too. Think about that. Scientists can now tell you that this specific dinosaur probably showed off its rear end to potential mates and likely had internal reproductive anatomy. That's how detailed our knowledge of this one individual has become. But they were not done. In 2022, another team led by Dr. Phil Bell subjected the same fossil to laser-stimulated fluorescence imaging. This technique uses specific wavelengths of light to reveal details invisible under normal conditions. They found something that had gone unnoticed for 20 years. Psittacosaurus had a belly button, technically an umbilical scar. When egg-laying animals hatch, the yolk sac that fed them during development detaches, leaving a scar. In most reptiles and birds, this scar disappears within days or weeks. This Psittacosaurus, estimated to be 6 or 7 years old and approaching sexual maturity, still had its umbilical scar clearly visible. It was delimited by paired scales running along the midline of the abdomen, the oldest belly button ever found. The first evidence that at least some dinosaurs retained their umbilical scars into adulthood, similar to crocodiles and some lizards. One fossil, colour pattern, camouflage strategy, habitat preference, reproductive display, developmental biology, all confirmed through actual preserved tissue, not speculation. Now think about every other dinosaur reconstruction you've ever seen. When you walk through a natural history museum and see a Tyrannosaurus rex model, how much of what you're looking at is based on actual evidence? The skeletal structure, yes. The basic body shape, probably. But the colour? The texture of the skin? Any behavioural implications? Educated guesses? Sometimes very educated, but guesses nonetheless. The Psittacosaurus specimen in Frankfurt demonstrates what is possible when exceptional preservation meets modern analytical techniques, and it exposes how far behind our standard reconstructions really are. Here is what bothers me. The 2016 colour study made international news. National Geographic covered it, the Natural History Museum in London wrote about it. Bob Nichols' model has been photographed and shared countless times. And yet if you visit most natural history museums today, their Psittacosaurus displays, if they have one, do not reflect any of this research. You will see generic browns and greens chosen by exhibit designers decades ago, before anyone knew dinosaur colour could be scientifically determined. The Senckenberg Museum in Frankfurt has the actual specimen, but how many other institutions have updated their reconstructions to match the published science? How many are still showing visitors outdated guesswork while peer-reviewed evidence sits in academic journals? Museums spent millions on displays that physics proves impossible. The kangaroo posture iguanodon, the swamp-dwelling brachiosaurus, the featherless dromaeosaurs. Every decade brings new corrections, and every decade exhibits lag behind. With Psittacosaurus, the gap is especially frustrating. This is not some obscure technical detail. This is the only dinosaur where we know the exact colour. One fossil has taught us more about dinosaur appearance than perhaps any other single specimen, and that knowledge exists right now, freely available in published research. So here is your challenge. Next time you visit a natural history museum, find their ceratopsian section. Look for Psittacosaurus or its relatives. Ask yourself, does this reconstruction reflect what we actually know? Is it countershaded? Does it show the forest camouflage pattern? If not, ask the museum why they are showing you guesswork when science has given us answers. One fossil in Frankfurt, lying on its back for 130 million years, has revealed more about dinosaur biology than any textbook will tell you. Its colour tells us where it lived, its cloaca suggests how it mated, its belly button shows us it kept developmental features into adulthood, its quills prove ornithischians had integumentary structures beyond scales. And it exists right now, you can go see it. The question is whether the institutions we trust to educate us will ever catch up to what one remarkable fossil has already shown. But let me leave you with something else to consider. If one exceptionally preserved fossil can rewrite our understanding of dinosaur colour, camouflage, reproduction and development, what happens when we find more? The Jehol deposits in China continue to produce remarkable specimens. Laser-stimulated fluorescence is being applied to fossils around the world. The same techniques that revealed the Psittacosaurus colour pattern have been used on feathered dinosaurs like Anchiornis, which turned out to have a reddish crest, and Sinosauropteryx, which had a striped tail. We're not guessing anymore. We have tools, we have methods, we can actually measure what these animals looked like. The problem is not scientific capability, the problem is institutional inertia. Museums operate on long timelines. Exhibits cost millions. Updating a display means admitting the old one was wrong. And dinosaurs sell tickets. Even inaccurate dinosaurs sell tickets. So the gap persists. Published research accumulates in journals while fiberglass models from the 1990s continue to welcome school groups. That's what makes the Psittacosaurus in Frankfurt so valuable. It's not just a fossil, it's proof of concept. Proof that when we actually apply modern techniques to exceptional specimens, we don't have to guess. We can know, and knowing changes everything. That's the story of Psittacosaurus, the parrot lizard that proved we can determine a dinosaur's exact colour, and that revealed we have been guessing about everything else. Check your local museum, see what they are showing you, ask if their displays reflect current research. Remember, the science is often years ahead of the exhibit. If they are still guessing when answers exist, you have every right to ask why.